Hello everyone. Today we're going to see a new problem, how to convert the given NFA to the equivalent DFA using lazy evolution method. Okay, so this is the problem. So Q naught on A, comma B, it has a self loop, and Q naught on A goes to Q1, Q1 on B goes to Q2. So Q naught is the starting state, Q2 is the final state. Okay, for our convenience, we'll write a transition table first for the given NFA. Okay, so we have Q0 state, Q1 state, and Q2 state. So we have a transition for two set of inputs A and B. So Q0 on A goes to Q0, comma Q1. Okay, so you can see in the diagram. So Q0 on A goes to Q0 itself. Same way Q0 on A goes to Q1 because it's a NFA. So on the given state, on the given input, it can go to more than one state. Okay, so that is possible in the NFA. So that's why we call it as a non-deterministic finite automata. So we can't say determine to exact state, more than one state it can go. So same way Q naught on B goes to Q naught itself. Same way Q1 on A. So Q1 on A. So there is no any state. So we'll declare that as a null state. Same way Q1 on B. So Q1 on B goes to Q2. Q2 and Q2. So Q2 is the final state, will denote with a star mark, and Q0 was the first state, will denote with the arrow mark in the transition table. So Q2 on B goes to null. Same way Q2 on A also goes to null. So both the inputs will be null because we don't have any input for the given Q2 final state. Okay, so this is the transition table for the NFA. Now we'll write a DFA. Okay, we'll see how to solve a DFA, how to get a DFA for this one. So first step is we'll start with a simple logic, that is Q1 state, Q0 state. Okay, so we'll take like this Q0 state on A input and B input. Okay, so Q0 on A. So Q0 on A goes to two state, that is Q0 itself and Q1 itself. So we'll consider that one Q0 comma Q1. Same way we'll see for the B input also. So Q naught on B goes to Q naught itself. So you can see the self loop. So Q naught on B goes to Q naught itself. Okay. So now the next state. Okay, the next state we should not take a Q naught state. We should see which is the new state we derived. So we got a new state that is nothing but Q naught comma Q1. Now we should consider this Q naught comma Q1 as a new state. Okay, and now we want to check for the A input and B input. Okay, so I'll solve it below this one. So how you'll check it? So Q naught comma Q1 on the given input A. We want to see the transition for this one. So transition of Q naught comma Q1 on A. It is nothing but we want to check for the both the input, that is Q naught on A, where it goes union join it with Q1 on A. The both the condition you want to check. So Q naught on A, in the table you can see Q naught on A goes to Q naught comma Q1. So Q naught comma Q1 union Q naught on A. So Q1 on A. Q1 on A goes to null state. If you join the null state and this set of elements, you will get the same state, that is Q naught comma Q1. Okay, so therefore the transition Q naught comma Q1 on A goes to Q naught comma Q1. So that is Q naught comma Q1. Same way we want to do for the B input also. Q naught on B, where it goes. Same way Q1 on B, where it goes. First we'll see Q naught on B. So Q naught on B goes to Q naught itself, and Q1 on B goes to Q2. So we need to join that also, that is Q naught comma Q2. Okay, so now we got a new state, that is Q naught comma Q2. So we'll consider that as a third state, Q naught comma Q2. Okay, so Q naught on A, where it goes, Q naught on A goes to Q naught comma Q1. Same way q2 on a, that is null state, so don't bother. So same way q naught on b, q naught on b goes to q naught itself. Q2 on B, Q2 on B don't have anything null state, so therefore it is Q naught. So already now we got Q naught and Q1. So Q naught and Q1 is already derived. Q naught state, Q naught it's already derived. So there is any no new state to derive, so we'll stop here. And wherever we see the q2 state, in whichever the combination we see the q2 state, we'll make them as a final state. So in this three states we have q2 in this one, so we make it final state. So this is our final NFA. From the NFA we have connected to a DFA. So for more convenient, we can give a names to the state. For example, if you have Q0 and Q1, you can give a new state as a state. Same way, whenever we have a Q0 comma Q2, so Q0 comma Q2, we can give a name as a B state. And we have a q0, so for q0 we can give a state as a C state. So wherever we have a q0, we can replace them with a C state like this in the table, and we can draw a new table. So C state and C state. So wherever we have q0 comma q1, q0 comma q1, we can declare it as a state. So this will be a state, q0 comma q1, q0 comma q1, q0 comma q1. Same way, wherever we have a q0 comma q2, we can consider them as a B state. So you can see q0 comma q2. So again q0 comma q1, again q0 comma q2, that is B state. So on the input A, on the input B, this is the new transition table with a simpler format, and you declare the q0 as a starting state and this B state as a final state. And for this one you can draw a DFA. Okay, so we can draw a DFA like this. So C state on A input goes to the A state, C input on the B input goes to the C state, self loop you can put C state on B input. Okay, same way A on A goes to self loop. So A on B goes to the B state. B state, and same way B on small a goes to capital A state, and B on small b goes to capital C state. Okay, so this is the final DFA for the given NFA. So you can consider this one also and draw a diagram, or you can give alternative single capital symbol state to make it simpler way, and you can draw the DFA like this also. Thank you for watching. Like and subscribe more for such videos.